In this video, we're going to look at the concept of density and the ideal gas law in order for us to calculate the density of a gas. To remind you of how density is calculated, we will take the mass and divide by the volume of a particular substance. In liquids, typically the units are grams per milliliter. However, in gases, we tend to use the units of grams per liter. With the ideal gas law, remember this is PV equals nRT, and one of the things that we're going to also utilize in order for us to calculate the density, we're going to have grams or mass in our equation. So if we're using the ideal gas law, we're going to have to take this unit of N, or the variable N, and change that into what it actually, the units that are used to calculate that. And that is mass divided by the molar mass. So this is the mass by the molar mass of that particular substance. So what we'll do is we're going to derive an equation for the density using the ideal gas law. And what we're going to do first is we're going to replace N with the equation grams per molar mass, and that will look something like what you see here. So in place of N, we have grams per molar mass. And then what we're going to do is we're going to solve for the units that will give us the unit of mass over volume. And that's what we would be essentially calculating as density. So we're going to move grams and put that over volume and put that all on the left-hand side. And when we do this, we end up getting an equation that looks grams over volume equals the pressure times the molar mass divided by the universal gas constant times the temperature. And essentially, we can rewrite that equation to look something like this, where the grams of volume gets replaced by that density symbol. So let's use this equation, our way to calculate the density of a gas, using the ideal gas law in that form. So this problem says calculate the density of Freon 12, which is CF2Cl2, at 30 degrees Celsius and 0.94 atm. So again, we need to use our equation, the density, and let's go back up. Density equals the pressure times the molar mass divided by RT. And so let's start plugging our values in, or we can actually write our values, make sure that down over on the right-hand side and make sure they're all the proper unit before we plug them in. And so we'll start with 0.954 atms. That means if we're using ATM for a pressure, our R needs to be 0.08206 liters atms per mole Kelvin. Our temperature is 30 degrees Celsius, 30.0 degrees Celsius rather. And that we need to make sure that's in Kelvin. So that ends up being 303.2. So we're going to go all the way to the first decimal place, and that would be Kelvin. And the molar mass, this is something we would have to calculate based on the formula of Freon 12. And given that there's one carbon, two fluorines, and two chlorines, I get this value to be a total of 120.91 grams per mole. Grams per mole is the unit of molar mass. Okay, so now that we have all of these, and I believe they're all in the correct unit, let's go ahead and start plugging these in. So pressure is 0.954 atm. Molar mass, 120.91 grams per mole. R, 0.08206 liters atm mole Kelvin. Times our 303.2 Kelvin. Check and make sure that you solved that right and got all the right units correctly by just canceling out the units. So ATMs cancel, Kelvin cancels, moles cancel. That leaves you with grams over liters, which is density. So we've got that check done correctly. So let's go through and put this in our calculator. And when we do this, round it to the third a significant figure, I get a value of 4.64 grams per liter. So this is how you calculate density using the ideal gas law.